Video help for our last problem in chapter 4 starts us off with a steady state situation. That means in this case we're talking about the steady state in the rotating reference frame. So that means that, if you've got something precessing exactly the same angular velocity as the rotating reference frame, it's at rest there. It's constant, it's steady state. So if we have dm dt prime equals 0, that means it will be actually steadily precessing in the lab frame. Well, if these derivatives, all three components are 0, then 4.37 through 4.39 all have their left-hand sides equal to 0, and we just have three algebraic equations. By the way, in those three algebraic equations, you have the most trivial, quick solutions. If B1 equals 0, so that we don't have, any extra magnetic field in the rotating reference frame, if we were right on resonance, if we don't have an RF pulse, then those three equations just trivially, that's just omega 1 equals 0. Remember, omega 1 is gamma B1. I just quickly get M0 equals MZ, and the other two components are 0. Now go back to omega 1 not equal to 0. I still have three simple algebraic equations to solve, and what you can do is quickly solve mz prime 4.37 in terms of my prime, and mx prime, you can solve that in terms of my prime from 4.38, and then you'll have an equation, you insert those guys into 4.39 and you'll get an equation for my prime, and the answers are easy to get, and you'll be able to compare them because they're actually given. I want to tell you a couple of things just that'll be kind of nice for the future reference. When we say order of omega 1, what I really, simply think of is that order of omega 1 is sort of proportional. Think of order of omega 1 proportional to omega 1. So actually, a mathematician would say, if I took the limit of order omega 1 over omega 1, it would go to a constant as omega 1 goes to 0. And if I were to talk to you about omega 1 squared, let me go over here where I've got a little room, order omega 1 squared, that actually, you can think of that as sort of proportional to omega 1 squared, so that if I divided that by omega 1, as omega 1 went to 0, that would vanish. But if I divided by omega 1 squared, then in the limit omega 1 go to 0, it would go to a constant. Well, so that's a notation with which you're maybe familiar, but I just wanted to mention it. Now in the denominator, the d that was given and that you're going to find arise when you solve 4.39, there is a term independent of omega 1 plus an omega 1 squared. So this is order omega 1 squared. And you remember that if you have 1 over, 1 plus an epsilon, that for epsilon small, well, you know that this is 1 minus epsilon plus epsilon squared. You know what? This is equal 1 minus epsilon plus order epsilon squared. Well, as a matter of fact, 1 over a plus b omega 1 squared will then be 1 over a plus something of order omega 1 squared. This is my epsilon, if you like. And this, in this discussion that we were making in this particular problem, we could neglect these terms if we only cared about keeping terms linear in omega 1. I actually wanted to mention one last thing, and that is this business about which quadrant we're in. If you were to define the tangent of the angle, say delta phi, that the vector m perp makes in the rotating reference frame, so the side opposite is my prime, the side adjacent mx prime. I've got the tangent of delta phi then as my prime over mx prime, and you'll see, from your expressions that that'll be proportional to an omega 1 times stuff over omega 1 delta omega times stuff. And if I always think of this as just positive, you have the ambiguity that you looked at, probably very early in your life, that you might think that if this thing came out to be, suppose this came out to be 1, you'd think that this was 45 degrees, but in fact it could also be pi plus 45 degrees, 225 degrees. And the way you check to see which it is look at the sign of omega 1. If omega 1 is negative, then each of these components is negative and you're in the third quadrant. If they're both positive, of course, you're in the first quadrant. And that's what that thing about adding module, the factor of pi, and the answer that we have. We actually have cotangent delta phi, which has the same sign issue.